Now, I again need to be, if I'm applying properties and conjectures that are drawn by rectangles and squares, I need to know what those are. Equal in length. Well, a general parallelogram, that is not true. It is in certain cases, but only if the parallelogram is also a rectangle. That's one of the things about a rectangle is the diagonals are congruent, and they use that in construction all the time to see if a doorway is square or if a wall is square. The diagonals of a parallelogram, well, what I do know about the diagonals of any parallelogram, they're not necessarily equal in length, but they do bisect each other. Sometimes they're perpendicular if it's also a rhombus, sometimes they're the same length if it's also a rectangle, but what's true of the diagonals of any parallelogram is that they bisect each other. And the diagonals of a rhombus are perpendicular bisectors of each other. Now, always, sometimes, never. Diagonals of a parallelogram bisect the opposite angles. Sometimes. And the sometimes works when it is a rhombus. The consecutive angles of a parallelogram are supplementary, always. The diagonals of a trapezoid are congruent sometimes when it's isosceles. And the diagonals of a kite bisect each other, never. Now, some people wanted to put sometimes, because if you think about a kite, one of the diagonals is the perpendicular bisector of the other diagonal all the time. But when you say each other, you're implying that there's a kite out there, at least one kind of kite, where both diagonals bisect. Each diagonal bisects the other diagonal, and that is just not true. If you think that there may be some confusion here, you might write a little note that one does, but the other one does not.